All right, I'm going to show you the power series, part two, the special cases. So there's just two special cases. So you can see, I want you to see them. I have these type your notes. I actually typed them all out with the answers, but I'll discuss through it with you. All right, and again, I get to choose, but we're going to do ratio tests. The reason why we're going to do ratio tests, there's a mix of just nastiness here. So, and we add one, absolute value. Or we add one, and then we divide by our series or multi-reciprocal. And we know this if it's less than one. If we can show it's less than one, but we've got to clean this up a little bit. Well, so the n factorial to n plus 1 factorial counts to be an n plus 1 on top. The extra 3 on the bottom and extra x plus 9 on the bottom. But remember, we're doing a limit as n approaches infinity. If I plug in infinity, the top is bigger. It's got 1 to none. So it's actually going to go to infinity. So since this is going to take me to infinity, it doesn't matter what number I plug in here for x. I can plug in 25 and I get 25 times infinity, and it doesn't have any effect. So it turns out this goes to infinity always. So it's not going to be convergent. There's no x value can make it convergent. There's only one x value that would stop it, is at the center. So what we say is it converges at the center only. And the center is what x is subtracting, which is -9. So my center is -9, and radius convergent would be 0 if they asked that question, because it's -9 is the only point that works. So whenever you get a limit of infinity, there's no x value that would make it work except at the center. So interval convergence, you can just say converges at center, x equals -9 only. All right, that's a -9 there. So converges at the center, x equals -9. So that's it. So that's a special case. If you have it going to infinity, there's nothing you can do. There's no x values that would make this work. So just the center, because the center will give you 0 times, anything which would be 0. We'd actually get a sum, okay? All right, it's that factorial on top that destroyed us. So let's try this one. So we add 1, again divide by ours, multiply. Again, that has to be less than 1. So if I cancel the x minus 7's cancel, the x minus 7's cancel, there's one more on top, and the n factorial and the n plus 1 gives me an n plus 1 on the bottom. This time, the limit's 0, always. Is it less than 1? Yeah, you can plug in any, actually want to plug in 10,000. 10,000, over infinity is still 0. It's going to approach 0. So this converges always. So interval convergence, if you want to say, negative infinity and infinity, always. Now the center is what x is subtracting. So the center is 7. Some people are like, is 0 your center? Any number is in the middle between negative infinity and infinity. 0 is the technical middle, I guess. But the center is 7. The radius convergence, if they asked one, would be infinity. And we have infinity in each direction for it. So factorial is the beast, as we talked about. If he's on top, he's going to just blow it up. It's going to go to infinity no matter what. It's just only the center will be the only thing that works at one point, okay? If factorial is on the bottom, he's going to make it go to 0 for sure. And what happens is converges always. There's no x value that couldn't make that convergence. So every x that we have will work, okay? So those are just two special cases when we won't have an actual numerical interval of convergence. Okay, and so there's your special cases.